have to look at this. All right, so this is what we're going to do today. You know, we're going to, on this page and in this chapter, we're going to, most often than not, solve a lot of chemistry questions. You see, so that is what we're going to do most often on this particular place. Okay, so let's look at it. And so that is what we have at the moment. There's a question. Okay, question number 1. You see that the chloralkali industry is an important part of the UK chemistry industry. The raw material is brine, a concentrated aqueous solution of sodium chloride, NaCl aqueous. Two products that can be manufactured from brine and chlorine and sodium hydroxide. Hence, the name chloralkali. A. Bleach can be made by reacting chlorine with cold aqueous sodium hydroxide. A solution of bleach contains the chloride compound sodium chloride. Write down the equation for the reaction taking place. Okay, so let's see. How do we write down such, equation? So first of all, we have our sodium hydroxide. So we say sodium, let's go here. Okay, so we have sodium hydroxide plus chlorine gas. That will give us sodium chlorate, ClO, okay, plus sodium chloride, Cl, plus water all the time. So at looking at this, reaction, you see that we need to balance the equation because we have 2 chlorine here and we have another 2 chlorine on the right hand side. But if we look at it carefully, we will see that if we put 2 in front of the sodium here, then we have 2 sodiums, okay? So that equation is balanced. So this is the balance equation that the examiner is expected us to provide. Okay, now the question in BI is that the systematic name for sodium chlorate is sodium chlorate 1. Other chlorate compounds exist such as sodium chlorate. Give the systematic name for sodium chlorate 3. Okay, so in this case, if you look at it, how do we name this one? So assuming, since the element is in a neutral state, we see that the summation of all elements within is 0. So when we assume the sodium is, we always know sodium is +1, and the chloride, which we don't know, we call it X. Then we add the oxygen, which is always 2 here, 2 minus, so that will give us -6 is equals to 0. So when we solve it, we know that the X will be equals to what? 5. Meaning the name of this compound we have over here will be sodium chlorate 5V. So we are solving the questions. Okay, now the II is when heated sodium chlorate disproportionate as shown in the equation below. Using oxidation numbers, explain why this is disproportionation reaction. Why? Okay, So first of all, we have to look at the chlorine in all states. So we are going to look at chlorine in formation of sodium chloride 3, as you can see over here. Then we look at chlorine in sodium ClO4, and the last but not the least is sodium chloride. Fantastic. So now, as we did for the one in II, how do we find the oxidation state of chlorine in each one? So here, this one will be sodium +1 plus oxidation state of chlorine here, we don't know. Then here, you know, it will be 2 minus, okay? So here, -6 is equals to 0, implies that Y is equals to 5 plus 5. In the same way, here's the sodium, always is going to be +1. Let me put a bracket, that will make it nice. Plus Y over here. This will be -8 is equals to 0, implying that Y is equals to +7. And here, in this case, we have sodium to be +1 again, plus unknown chlorine, which is equals to 0. And this implies that Y is equals to -1. Fantastic. So, chlorine has been oxidized and reduced. You see, so we can say chlorine has been oxidized and reduced. Well, if we look at the reaction perfectly, we can also say we can draw it in a different format that will help us. If we say, if we look at our reaction, when we had our 4, okay, cancel this. When we had our 4 sodium chloride, O3 to 3 sodium chloride, O4. Okay, if you look at this reaction plus the sodium chloride produced, if we say from here, this reaction, we see that the sodium here that helps us to produce an oxidation state over here was +5 for that of chlorine. And when we get to this place here, it became +7. So you see that this is oxidation state because the chlorine has gained a positive charge here. As we started with 5. Now, when we look at the same reaction, when we come to sodium, we see that sodium is -1. And obviously, this is a reduction reaction, so it has reduced, you see. So we say reduction reaction. So that answers question II. Beautiful. So that is how we solve such question. Now let's look at question number 2. Yes, question number 2. Okay, as you can see, the C part says chlorine has been added to a drinking water. Chlorine has been added to drinking water for over a century. Recently, some scientists have put forward the case for not chlorinating drinking water. This is because chlorine may react with organic compounds in the water to form CH3Cl, also beta chloride. Okay, so the first question says, state one valid reason that supports the scientist's case and state one reason why chlorine should be added to drinking water. Okay, so the first one is chlorine. Chlorinated hydrocarbons are carcinogenous. You see, so we can say chlorinated hydrocarbons are the word is kerosene. C-A. Oh, come on. Clean this. Good. So they are kerosene. This is C-A-R-C-I-N. Carcinogens. Okay, so we say chlorinated hydrocarbons are carcinogens or toxic. Okay, so if it's toxic, then obviously it's going to be poisonous. Okay, so that's what we say. We should state one valid reason why that supports the scientist's case. That's okay, because that is the reason. Obviously, the next one is say what? Why chlorine should be added? Why one reason why it should be added? Well, it should be added because now we know it should be added because it kills microorganisms. Okay, it kills one. It's A, it kills bacteria. B, it kills germs. Okay, and C, you can also say it kills microorganisms. Okay, and because of that, somebody will say it makes water safe to drink. So it makes water safe to drink. Okay, so it kills. So in a way, that's the main answer to this question. Okay, so that is what we have. Now, the next question, it says we should draw a dot and cross diagram Okay, so let's write our answer here nicely. So chlorinated hydrocarbons are carcinogens or toxic. Okay. Now the next part, we say A kills bacteria. Okay, B kills germs. Okay, and C, we can say, as we say, it kills microorganisms. Okay, And the last part, it makes water safe to drink. So that's more reason why we should add chlorine to our daily, water. So let's put the answers to where they belong. I hope everybody's following. Okay, so we have this. I clean this. Okay, so that answers the C part of our question. Now let's look at it again. On an II, say draw a dot and a cross diagram to show the bonding in the molecule of metal chloride. Show the outer electrons only. So that's how we go about it. So let me see if I can open a page, maybe further down. Okay, so here, maybe I can draw it somewhere here. So I say, can I draw a circle from here too? That doesn't help. Right, okay, so let's draw with our hand. So the first one, we have the carbon, C. Then hydrogen here, which is a dot and X. Then we have, so this is hydrogen. Then this one is X and a dot. Then this one will be hydrogen. And this, okay, 2 electrons here, another electron, another electron here, and another electron here. And this is what chlorine. Okay, and the last one here we have dot and an X. Okay, and the last bit, we come this way, like that. Okay, this is a dot and an X. Then this is a hydrogen. So this is how that structure is supposed to look like. Okay, now let's go up and see so this is the II. You should know that the electron pairs in covalent bonds shown over here. Okay, as you can see, the dots and crosses, the molecule of metal chloride has been illustrated. So you see that CH3 chloride. This is how we draw the structure. Now let's look at the name, the shape of the molecule. And we all know it's a tetrahedral. Well, some people can also say tetrahedron, which is the same. Awesome. Now the question is answered. Okay, so now let's look at the D. The D part. It's a sample of brine. It's a concentrated aqueous solution of sodium chloride, which we have over here as NaCl aqueous. Describe a simple chemical test that you could carry out to show that brine contains aqueous chloride ions. However, would you confirm that no other halide ions are present? So how would you confirm that no halide ions are present? Include an ionic equation in your answer. Good. So this one in the lab, we say add a certain amount of silver nitrate aqueous solution. Okay, so we add to our solution, okay, and we stir. So when we add silver nitrate solution into the compound, okay, it will form a white precipitate. A white precipitate. white precipitate. Then, so our equation is going to be silver plus chloride negative ion, and that gives us silver chloride molecule. Now, after that, we add a diluted, so a dilute amount of NH3 and the precipitate, will what? Completely dissolved, or disappear. So that's how we go about it. Now, friends, I think it's been lovely as we all have come together to solve this equation. Fantastic. I will see you guys again. Have a